So who can define causation? We're on number 2 now. So causation.
One variable has a direct consequence on another variable.
Okay.
Causation, a causal link establishes a direct relationship in which B follows A. If A occurs, B is unavoidable. If B is occurring, A can be inferred. Proximate causation is direct cause of an observed event. Distal causation addresses the underlying or root causes.
I'm sorry, can you repeat that one more time?
The whole thing, or just?
Yeah, the whole thing.
A causal link establishes a direct relationship in which B follows A. If A occurs, B is unavoidable. If B is occurring, A can be inferred.
Slow down a little bit. My mind doesn't work that fast as day and night.
If A occurs, B is unavoidable. If B is occurring, A can be inferred. Proximate causation is direct cause of observed event. Distal causation addresses the underlying or root causes. A baby is born because an egg is fertilized is an example of proximate causation. A baby is born because a couple desire to have a family is distal causation.
I really like the first part of it, that you try to talk a little bit about how one is going to happen independently of the other one. It's going to affect the other one. So that's a really good element of causation. It's a very good way of trying to detect in econometrics which one is causing the other. So that's one of the problems that we have. A lot of times we're going to end up having some of the statistics indicating that there is, at the very least, some sort of a correlation, and we don't know if there's going to be any causation involved. And being able to figure and solve that problem out is a big part of econometrics, and more specifically in modeling how you want to end up going about your econometrics, and how you want to model it, how you want to set it all up, and taking into consideration in the back of your mind that, well, one is going to end up affecting the other one, and it's going to be happening relatively independent of everything else. That's a very good starter to take into consideration while you're modeling these. Anybody else? Causation. In your own words, yes.
I would say that this is a deterministic relationship between two variables, one determining the other. And it implies directionality too, that the one variable eventually influencing the other one, and it doesn't work the other way around.
Right, okay. I think I would agree with that, right. So one is causing the other one, and A is causing B, B cannot be causing A, right? It's never going to be the case that B will cause it.
Is that a requirement for causation?
Excuse me?
Is that a requirement that they can't control the direction? That there can't be no reverse causation?
I don't know if it's a necessary requirement of it. I know that when it comes to modeling, it's a nifty trick to have to try to figure out which one should be your independent variable, which one should be your dependent variable, or one of the very good ways of controlling or something like that, or taking that into consideration is running a time series regression, where you're taking into consideration the time element. And if you can somehow control that dimension of time inside of your regression analysis and introduce that into the model, then all of a sudden the one is going to happen, and it's going to end up affecting the other one, and therefore you're never going to have that coming back the other way around. So that's running a time series regression is a very nifty little trick to determine which one will cause the other one. Yes?
Does Dr. Buck use rats at all? You're talking about time series?
I think rats and Swanson's doing. I don't think he does. I don't think, he's not adverse to it. I can't imagine that he would be adverse to anything, but I don't think that he does that. But rats is a very good time series. That's what they're basically for. Time series modeling. Rats is just like another R or another SPSS or whatever statistical package that you might use.
I just have a question. Did you say there's a way to determine if you set your model up incorrectly for causation?
Well, I don't know if I would say that confidently. What I would say is that there are ways that you can try to sift out, so to speak, which variable will be causing the other one. And an example of that would be a time series regression. So if you can manage to do a time series regression, and, then you know that the one in one time period is independent of the other one that's affecting the other one. And it's one way of trying to determine, well, therefore we know this is caused that. Because you control for times.